Okay, so again, don't go at the module number, whatever was written. So today, see, as in last class, I completely focused on the data types, right? And why I completely focused on data type is because everywhere, whenever we are selecting any, any test for any assumption and for any type of data, we need to understand the data first. Okay, before going into the test types, before we go to the different types of parameters, parametric test and non-parametric test, and before regression analysis and multivariate analysis and all, we need to understand our data. So in last class we understood the data, and there were 4 types of data. Overall 2 types of data, one is qualitative data and one is quantitative data. So quantitative data again was differentiated into 2. First was continuous and then discrete, right? And then if we talk about the qualitative data, then qualitative data also was 2 types. One was ranked or ordinal, where there are where there is an order or rank, or where there is no rank or order, right? So non-ordinal, non-ranked, and that type of data is called as nominal data, right? Nominal data, correct? So nominal data also is the binary or dichotomous type of data. So this is about the data, and now when we understood the data, we have to go to the analysis, right? We have to go to the biostatistics. So in statistical analysis, there are 2 major types of analysis. Okay, there are 2 major types of analysis. One is descriptive analysis and one is inferential analysis. So what is the difference when I'm talking about statistical analysis? So this is one descriptive, one inferential. So what is descriptive? Descriptive means not very specific tests. Okay, we are just defining the population. Okay, we are just defining the population. So population means your any test population or any any kind of population where you are performing the simplest statistical analysis, where we are just applying the simplest statistics. Simplest statistics means when I'm talking about defining the population. So defining the population means either I'm talking about central tendency or distribution. 2 things I'm talking about. Okay, in simple statistics, in descriptive analysis, I'm talking about only 2 things. One is central tendency, one is distribution. Okay guys, one is central tendency, one is distribution. So what is central tendency? First of all, let me tell you. Central tendency is nothing but the point, okay, the center around which the entire population is lying. Okay, around which the entire population is lying. Let me give you an example here. Suppose I'm going to some I'm going to one class. Okay, I'm going to one class and I'm asking them, what is the age of your class? What is the age of your class? If I'm asking like, okay, tell me, if I'm asking, just tell me the age of your class, right? Class means there are 100 students, right? So you will not tell me the age of each and every student, right? That is not the age of class, that is the age of individual. So you will be taking the age of class is maybe 20 years. So this 20 years is the entire population. Entire population means, when I'm talking about entire population, that could be either mean, mode, or median. That could be either mean, mode, median. So that is the central tendency, we call it, right? So maximum of the people are lying into the 20 years, lying around the 20 years. Suppose I am asking you the age of 10th class. So usually the age of 10th class will be nothing but 15 or 14 years or 16 years maximum, right? The central tendency, mean, mode, median, anything, majority of the students will be around 14-15 years of the age, right? If I'm asking about the 10th class, right? Nobody can say like entire class is 18 years, because as per the government rule also, as per the normality also, the 10th class means 10 plus 5, right? Usually 5 years of the kid goes to the school. So the entire class, if I am asking to represent, that will be 15 years for 10th, right? So that is like we are talking about the entire population in one number, right? Wherever mean is not possible, we talk about mode. Wherever mode and mean is not possible, we talk about median. So we just talk about central tendency, right? That is a central tendency. And the second term here is distribution, right? Now, if I ask you number of number of girls and boys in the class, so you will tell, sir, there are 70 girls, 30 boys, right? Or out of 100, so 70% girls, 30% boys. So that is nothing but the distribution, right? I am distributing your class upon gender, right? I am distributing your class upon gender. Same thing if I ask, tell me the class age per the distinctions, first class, second class, third class, and failed. So that means I am distributing your class based upon the marks, right? Based upon the marks. Similarly, if I talk about any population in medical science or if any project, so when I'm talking about, tell me about how many men and women are there in the population, right? And then tell me about how many are having comorbidities and how many are no comorbidities. So that is also gender, I mean, that is also the distribution, right? If I talk about, okay, how many diabetes, how many non-diabetes, how many hypertensive, how many non-hypertensive, right? Or how many in the group A, how many in the group B, and at any basis, right? So that means I'm distributing my class, I'm distributing my population into different things, right? Different things, or maybe based upon the age group, based on the age group, like, okay, how many are adult, how many are, adolescents, how many are elderly, or how many are young adults, right? So that is nothing but the distribution. And distribution and distribution and central tendencies are the simplest calculations when we are working on the data. I think someone is raising hand. Can you please, yeah, please, Dr. Harikran, please ask me if you have any questions. You have raised the hand. Please unmute yourself. All right. Any questions you are asking, Dr. Harikran? Oh, I don't think you by mistakenly raised the hand. No worries. Okay, fine. So this is the descriptive analysis, right? When I'm dividing, I mean, when I'm checking the central tendency or distribution, I am doing the descriptive analysis. That means we are not, putting any kind of specific test here. I'm not putting any kind of specific test here. But when I'm talking about the inferential analysis, that means I am doing the typical statistics. What is typical statistics? If I just talk about these distributions, right? So tell me the significant difference between gender. Tell me the significance difference between age groups. Okay, tell me the difference between group A and group B, right? So when I'm talking about difference means I'm looking for some kind of p values. Okay, so there are multiple inferential analysis, not only one. There are, independent t-test, dependent t-test, and there are multiple more things which can be done when we are doing the inferential analysis. Like, we have parametric tests, we have non-parametric test. In non-parametric test, we have Kruskal Wallis test. We have, multiple things are there. I'll tell you all the list. Okay, so those are which are not the simple statistics and which comes under the typical analysis. Typical statistics are known as inferential analysis. Inferential means these are needing any kind of intervention. And based on that, we will be coming to the outcomes, right? So that is inferential analysis, right? So as we can see here, inferential statistics make inferences about the population using data drawn from the population, right? So that is the normal statistical analysis. So let's talk about descriptive analysis, right? Let's talk about descriptive analysis. So descriptive analysis is nothing but, see, as I told you, descriptive statistics used for describing the properties of data set. So what is data set? Nothing but the population, right? So first, measuring the central tendency. So that could be either mean, mode, median, or then frequency and percentage, then Frequency in percentage means, you know that out of 100%, how much is that? That is frequency, and that is also percentage, right? Frequency and percentage, and then measure of dispersion and variation. So what is dispersion and variation? That is also the third thing what we use. So when we don't know the exact thing, see, mean does not represent the entire thing, so we write usually, if you have seen, mean plus minus SD, right? Mean plus minus SD. So to describe the actual difference, or perfection, okay, or precision, we call it precision, okay, to define the precision along with central tendency, right? Central tendency, we go for dispersion and variation, and there are multiple things. Multiple things means, first of all, standard deviation, then standard error of mean, then confidence interval. There are multiple things, right? And variance also. Variance. So variance, standard deviation, SEM, CI, right? These are the things of dispersion. Dispersion means there is some difference among the population. There is some difference among the population, and those differences can be, can be defined in form of either variance, standard deviation, SEM, and confidence interval, and those will be associated directly with our central tendency, nothing else but central tendency, right? So these are the normal description of data and distribution of data, as I told, right? So this is how we describe our data, right? So what is central tendency? Simple, nothing important in this. Central tendency, the point in the data distribution around. So most of the observations, most of the data is concentrated around this point. As you can see, this arrow, this is the central tendency. So most of the data is around this only, okay? Most of the data is around this point. This point is central tendency. This point is known as central tendency, right? Here also, if you look at this curve, it is going high and then it is going, so in the middle point, the central point is either mean or mode or median. So it could be anything. Okay, I'll tell you how it distributed, how it is, sometimes, it vary depending on the data. But usually when we are talking about the central tendency, it is in the central around which the entire data is lying. Okay, around which the entire data is distributed, right? So the central point of any data is like where the maximum data is around. Okay, where the maximum data is around. And there are three measures for central tendency. One is mean, one is median, one is mode, right? So let's talk about the uses of central tendency before we go to mean, mode, and median. So why we use the central tendency? First of all, as I told you, to get the single value about the entire population, right? If I'm asking about the age, if I'm asking about the distinction, if I'm like, I can ask you anything. What is the average mark of your class, right? What is the average age of your class? What is the average weight of your class, right? I can ask you anything. What is the average height of your class, right? So, or what is the average height of this group of officers, whatever is the question. If I'm asking you to define the population that is in the single value, that is called as central tendency, right? To facilitate the comparisons, again, as I told you, distribution. If I'm asking what is the age of female and male in this group, right? So this is, again, I am just distributing the population into two groups, female and male, according to gender. And again, I'll be telling you the age of females and what is the age of males. So again, I'll not be counting, I'll not be telling the individual age of males or individual age of females. I'll be telling the group age. So this is the mean age of females, this is the mean age of males, right? This is the mean age of group A, this is the mean age of group B. That is like we are again facilitating the comparison between groups due to according to central tendency, right? So central tendency is used to define the population in any form, either the entire population or the groups between, or the comparison between groups, right? And then this is also used to check the variances. So without the central tendency, we cannot go for the variance, SD, confidence interval, etc. We cannot go for that. We cannot go for the precision check. We cannot go for the precision check without the help of mean, mode, and median. Without the help of central tendency, we cannot go further for the precision in any population. So we need the mean, mode, median, or central tendency, right? So what is mean, mode, median? Let's understand. So first of all, what is population mean? Okay, population mean is defined with mu, right? This is the symbol of mu. And population mean is nothing but if you have 100 people in class, sorry, if you have 100 people in class, you have to add the individual values n1 plus n2 plus n3 plus n4 and plus n100 and divide by the n, right? So here the big N is the total number. Okay, big N is the total number of people in population. Okay, people in population, right? People in the population or the group. Suppose there are 100 people and I ask you, what is the mean age of your group? What is the mean age of, or what is the age of your class? So what you will do is you will calculate individual, you will add all the individual values, you will add all the individual ages of all the students, and then divide by the 100, and that you will tell me like, okay, this is the population of my age. This is the one number which I can define by which I can take the help to define my population, right? So that one number is your mean, and that comes with the addition of all the values divided by the total number of population or total number of individuals in the group, right? So for a population with finite numbers, general formula is this. So epsilon n x1 is nothing but n1 plus n2 plus n3 plus n4, like all the individual value, addition of the all individual values divided by n, the total number, and then you will get the mean. So that you will get the mean, right? So mean computed is like by this formula, right? So see, it is calculated by adding up the individual observations and dividing by the number of observations, right? So it is suitable for the continuous type of data. Now look at this, why the first class is important. Mean can be done only for the continuous variable types. Okay, we cannot check the mean for categories. Okay, we cannot get the mean for categories. How can we get the mean for categories? If there are 3 categories, what is the mean of category? Tell me. Can someone tell me, if there are 3 categories, what is the mean for 3 categories? Can someone tell me what is the mean for 3 categories, guys? Can someone tell me what is the mean for 3 categories? So mean is suitable to summarize only continuous type of data which has normal distribution. I'll come to the normal and abnormal distribution, that's different, but continuous data is important. We can check the mean only for the continuous data, right? Why we cannot do it for categorical data? Tell me, guys. Anyone? Why we cannot check mean for the categorical data? See, there is group 1, there is group 2, there is group 3. Okay, these are the 3 groups, not individuals. Can you tell me the mean of these 3 groups? Can you tell me the mean of these 3 groups? Two. Okay, anyone else who wants to put their answer? See, that is the confusion for all of you. That is a trap. Okay, that I can say it's a trap, because we cannot check the mean for groups. See, we can check the mean only for the individual variables. Okay, we don't know how many people are there in the group 1, how many there in the group 2, how many are there in the group 3, and if they have the same age, if they have the same height, or whatever I'm asking for, if individual have the same height and weight, right? I am not sure. So for the group, I cannot check the mean. Understand? I cannot check the mean until and unless I am not having all the meanings here, all the values here, all the observations here with me, and total number of the people, total number of the individuals here. So for the groups, for the categories, mean is not at all possible because I don't know the individual information here. Okay, I'm not having the individual information here. Without just telling that group 2 may be having the 100 people, group 1 is having 50 people, group 3 is also having 100, group 3 is 30 people, how can you say that group 2 is the mean? No, in the groups, in the categories, we cannot say the mean. Okay, we cannot say the mean, right? So in that case, we will go for something else, not the mean. Mean is only for the continuous type of data and normal distribution of the data. Okay, normal distribution of the data. So what is normal distribution, guys? What is normal distribution? So normal distribution is nothing but if your data is let me give you an example. Let me give you an example. See, I'm talking about 10th class. Okay. I'm talking about 10th class, and you guys are having 100 people in 10th class, right? 100, this is the n. 100 is equal to n, right? So if I'm telling that the age of your 10th class is around 14 to 16, that data is called as normally distributed data. Why it is normally distributed data? Usually in 10th class, the age of the people will be 14 to 16. Usually, okay. Usual data is normal data. Usually, usual data, usual distribution is normal distribution. So if I'm telling in the 10th class, all 100 people will be having either 14, 15 or 16 years of the age, or maybe some of 17 also. Let's count 17 also. So that is a normal distribution. Okay. But suppose if I'm telling that in the 10th class, 97 people are having 14 to 16, and there are three students who came and joined the school late in their later age. So one's age is 30, second age is 36, and third age is 42. Okay. So this is abnormal. This is abnormal, or this is not normal. Okay, this is not normal for the 10th class. Okay, it's not that they cannot study in 10th class. It is not that. That is illogical. They can study in the 10th class, but if I am asking statistically, this age is not normal. This age is not normal. So this distribution type is known as not normal distribution, and this distribution type is not known as normal distribution, right? So now how, if I'm writing here that mean is suitable only for the continuous variables, continuous type of data with normal distribution. So suppose if I'm talking about these 100 people, these first 100 people, which have, I mean, these all have 14 to 16 years of the age, right? So everyone's age will be counted, individual's age will be summed or addition, and after adding all the ages, we will divide by 100. Okay, we'll divide by the 100. So what the mean age will come? Either 14 or 15 or 16, right? This will come. This will come, right? So this is the normal mean age. This is the normal mean age for this group. But if I'm adding 97 ka pura 15, 16, and then plus 30 plus 36 plus 42. Okay, so normally the number is 100 only, but this 30 is representing two people, this 36 is presenting 2.5 people, this 42 is presenting again 3 people. So what does it mean? Try to understand this. What does it mean? Try to understand this. So see, this is actually normally the age of 2 people. This is age of 2.5 people. This is age of 3 people. 15 into 3, almost 45, right? So when we are normally telling the sum of this all will be equal to 100, I mean 97, 99, 101, 104. So this is the sum for 105 people. Okay, this is sum for the 105 people. Okay, now if I'm adding these three values, normally this is the 100 only, the number is 100 only, but this age usually should be for 105 people. 105 people. So that is not normal. So these three values are known as, see, these three values, like I'll write somewhere else. So these three values, 30, 32, 45, whatever is there, are known as extreme values. Okay, extreme values, okay, extreme values, or what? Extreme values or outliers. Okay, outliers. Okay, these are outliers. Why outliers? Because these does not belong to the normal distribution of the data, and these can influence the mean. So if I am now getting or calculating the mean of this group, including 30, 36, or 42, the mean will not be 16 or 15. The mean will go to 18. Okay, so only three people, only these three values are influencing the entire group. Only these three values are differentiating a lot in the group. So see, these three values are influencing other 97s. So if I'm talking again in the one scenario I'm giving you, if you want to check the mean of 97 people, it will again 5. Okay, and if you want to check the mean of these three people, it will be somewhere around 35, right? So these three values are influencing the entire data. Okay, these three values are influencing the entire data, and these three values are known as extreme values or outliers, right? So in case of outliers, mean does not work because mean can be easily influenced by the outliers or by the extreme values. So in such cases, the data which has the outliers or extreme values is known as not normal. Okay, not normally distributed, and the data which have no outliers or which have no extreme values is known as normal distributed data, normally distributed data. Now one more thing you have to keep in mind when I'm talking about extreme values or outliers. Outliers could be either positive or negative. Okay, positive, as you can see here, 30, 32, 45. If I'm talking about negative or extreme values but in the negative side, that could be maybe someone is very like highly intelligent and prodigy. His age is 9 years and he is in 10th class. Someone else whose age is 8 year and in 10th class. There are prodigies, right? There are prodigies who are doing PhD at the age of 18, who are doing PhD at the age of 16 years, right? So if someone is very special, but they are special for themselves, definitely they are special for the society, but they are not special for the statistics, right? Because they are outliers or extreme values in the statistics, either negative or positive. Understand? So I hope the normality of the data distribution is very clear for all. So what are the demerits of mean, as well as the merits, and like where we can use the means, you understood? But what are the demerits? Simple, as I told you, extreme values, extreme observations influence or affect the mean very much, right? It is not suitable when there is some data is missing. When some data is missing, like suppose in these 100 people, today I'm asking what is the mean age of your class, and only 85 people are there in the class. Only there are 85 people in the class, but the strength of the class is 100. Okay, strength of the class is 100. So what you will do is you will just add 85 values and divide it by 100. You cannot divide by 85. Okay, you cannot divide by 85 because I'm asking about class means all the 100 people. So your age, mean age or mode, whatever is there, it will be influenced, it will be affected. Okay, so again mean will be impacted, and that's why mean calculation is not again suitable for the missing data or missing values. Okay, and not suitable for qualitative data or ordinal data. Definitely, as I told you, this is not suitable for qualitative data. Only continuous type of data is it is only suitable for the continuous type of data. Understand, guys? Mean. So this is the mean example. As I told you, like we will add all the values here, divide by, there are 8 values, 1 2 3 4 5 6 7 8, and this is the mean of the this group, right? Now what is median? So median is again one of the central value. but there are different types of calculation. Why we came up with median and mode? Why we came up with median and mode? Just to avoid the demerits of mean, because median is not, or median cannot be influenced by what? Extreme values. Okay, median cannot be influenced by missed values. Okay, median cannot be influenced by missed values or extreme values, right? Why we cannot do that? Because usually median is not the number. Median is not the number, but median is the number of observation which comes in the middle of the entire population, suppose there are again 100 people, and we have to keep them in either ascending order or descending order. Usually we keep them in lowest to highest, ascending order. Okay, ascending order. So again, let's go to the example of class. Age, so like 13 13 13 13 13 14 14 14 15 15 15 16 16. Okay, so the 58 number and 51 number, this is n. Okay, number of the observation, this is the 58th person, this is the 51st person. Okay, this is the 58th person, this is the 51st person in the row. When I'm ascending all the age, we will just calculate the age of 51. That might be 14, that might be 15, divided by 2. So 19 divided by 2, 29 divided by 2 is 14 and half. So this is the mean age. Okay, why this is the mean age? Why this is the median age? No, I'm so sorry, that is not mean, I'm talking about median. So this is the median age of the class, 14 and half. Why I have added 50 plus 51st? Can someone tell me why I have added 51 plus 58th meaning value here? Sorry, why I have added these two? Because see, look at this, there are two things. Okay, there are two things. One is odd number, one is even number of observations. Okay, look at these two. So when I am calculating the median, I have to arrange everything in the ascending order, like from low to high, from lowest to highest, and then whatever is the middle value. If the n is odd, n is total number of observations, n is total number of observations. Okay, total number of observations, right? Total number of observations. If the total number of observations is odd, right, 5, so I'll take the n plus 1 divided by second value or observation. Okay, so n is 5, 5 plus first, 5 plus 1, 6, 6 by 2, third. So I'll take third value. Okay, I'll take third value. Similarly, if there are only 99 students, then what I'll do is 99 plus 1 divided by 2. So which value? 58th value. I'll take the 58th value, the value of 58th children, right? So I'll take this 58th value. This is the median for the population of 99. And if I'm talking about 100, as in my class there are 100 people, so look at this formula will work, even number of observations. Then which formula will work? The formula will be the two middle numbers. So what are two middle numbers? 51 50th plus 51st, okay, by 2. Okay, so here now I'm not adding the 50 plus 51. Okay, I'm adding the observation, whatever is the value of the observation. So value of the observation, anything, like suppose here this was 5, so 123 is the third number. So median here is 123. But in case of even number, there are 6 people I kept in ascending order: 117, 120, 123, 125, 127, 127. Right, so these are the 6 people, even number. Now if I want to check the median, so what I'll do is I'll take both middle values, 123 plus 125 divided by 2. So median here is 124. Similarly, in the class of 100, I'll take 50th and 51st, right? Observations. So either it would be 14, 15, 16, whatever is there, these two values will be added, divided by 2 will be our median. right? So now why this is not influenced by the extreme values? Why this is not influenced by the extreme values? Suppose in the class of 100, started with 13, okay, 13 years, 14 years, 15 years, and this is like first number 2 3, and we came to 49, 50, 51, and here 97, 98, 99, 100, right? Sorry, 100, right? So this has come here again, 14, 14, 15, whatever in the middle, and then 97 is also 97 is also like suppose 18, okay, and then 98 is 32, 35, and 42, whatever we have decided, right? So now in the calculation of median, only these two observations will be taken, okay, only these two observations will be taken. So there is no meaning of having outliers. Outliers are not at all useful. Either they are positive or they are negative. Those will be left from the median calculation. Those will be left from the median calculation, and those are not influencing the median at all. Understand? Understand how median is useful than mean. So in the calculation of median, there is no use of outliers at all. Outliers will either come first or come last. There is no use in between, right? So if there is an outlier also, if there are some outliers also in the data, in that case we don't go to the mean for central tendency, but we go to the median. Understand? I hope it is clear for all of you, right? Then what is, see, merits? It is not affected by extreme observations. Useful in the skewed distribution. Skewed distribution means either negative or positively not normal, right? It can be dealing with the ordinal data, and it can be computed if some data is missing also. Like some data is missing also, as I told, there are 85 people. So what I'll do is I'll just write all 1 to 100, and 85 to 100, what I'll do is I'll write 0 0 0 0, or I'll write missing missing missing, whatever I'm writing I'll write missing missing missing, but still I'll take 50th and 51st observation to calculate the mean. So no use of missing data. Missing data will either come first or either come last, right? You can keep it first or last, but it will not influence the middle value. So median has some great merits over mean, but mean is precise than median. That's why we prefer mean if the data is continuous. Otherwise, if data is not properly distributed, if data is having extreme values, if data is having skewed, if data is skewed distributed, or if there are some missing values, then we go for median, not mean, right guys? We go for median. So now that distribution, remember this slide is very important, and this slide will be again helpful in each and every assumption when we are deciding the tests. When we are deciding the test, each and every assumption will be, you know, asking us if the data is normally distributed or not normally distributed, and based on that only our data types will be useful, right? So see, the best part is B. The best part here is B. So B means no skew. B means no skew and normally distributed. So in the B, what you can see is, see, look at this. Look at this. In the B, if there is no skew or normally distributed data, mean, median, and mode will be at 1 point, this 1 point only. Okay, like if I'm asking about normally distributed data, normally distributed class of 100 people, so mean will be my mean might be 15.5 years, median might be 15, and mode might be 15. So these are almost similar. These are almost at 1 point. The central tendency of the entire population, either this is mean or median or mode, all are at the one place, right? So that is called as no skewness or normally distributed data, correct? And if I'm talking about the not normal distribution, okay, so not normal distribution could be either in negative direction or in positive direction. So what is positive and what is negative direction? So when I'm talking about positively skewed, so what is positively skewed exactly? What is positively skewed exactly means, your mean will be high. Mean will be higher than mode and median. Okay, your mean will be higher than mode and median. Your mean will be higher than mode and median. So data is having some positive outliers. Okay, positive outliers. You can see most of the things should be normal. I mean, see, as I told you, if there are three abnormal people with the age of 30, 35, and 42, those people are outliers positively. So they are influencing the mean to go to the positive side, mean to go higher than median and mode, higher than median and mode. So that is called as positively skewed. And in the same opposite side, if the mean is lesser than median and mode, see, this is the x, this is the y, so this is the central point from where the data is started. So in this, mean is going lower than mode and median. Okay, mode and median, mean is far away, mean is going to the negative side. Okay, lesser than median and mode, right? So that means the data is not exactly lying around the mean, but mean is lesser than the actual central tendency. Understand, this is the central tendency. Mode and median are the central tendency here, but mean is influenced by the negatively skewed or negative outliers or negative extreme values. Right here in the positive skewed, the mean is going again the far away from the central tendency, from the mode and median, just because of the positive outliers or positive extreme values. Understand? So this is normally skewed data, this is not normally skewed data. These two are not normally skewed data. And again, if we define, one is positively skewed, one is negatively skewed. Understand? Simple. Any questions, guys? Okay, then mode. What is mode? Mode is the third for the central tendency, to calculate the central tendency. So mode is nothing but the most frequently occurring value. Suppose I'm talking about the 100 people again, and there are 13, 14, 15 and 16 years of the age. I mean, these three numbers are there. So what is most frequently occurred? Like in 100, age 13 is 26 people, age 14 is 25 people, and age 15 is 46 people. Okay, and rest are 16, right? So what is the highest number out of 100? 46 people are having 15. Okay, so that is like most occurring number. Okay, out of 100, 46 people are having the 15 years of age. So this 15 is nothing but the mode of the entire class. Wherever we cannot calculate the median, wherever we cannot calculate the mean, we can go for the mode. We can go for the mode, right? So this is the most frequently occurring value. Okay, again, like we can, to easily calculate, we can again keep those things in, what we say, in the ascending or descending order, and we can check which number is mostly occurring there, right? And that number is your mode, right? So that's the traditional things, right? So it is suitable for discrete or categorical data. Okay, in such cases we go for discrete or categorical data. So how the categorical data? As I told you, group 1, group 2, group 3, number of observations in which this is high, and then we can calculate, we can check in which group the highest number is occurring, and based on that we can go for the categorical data mode. Okay, so we cannot check mean and median here, mean and median we cannot check here, so we go for mode in the discrete or categorical type of data. There are multiple categories, right? Like the pain score for 100 people, so pain 1 2 3 4 5 10 for 100 people, whatever is occurring more is your mode for that population, right? As you can see here, number of children per family, some is having 0, some is 1 2 3 4 1 2 3 4, so most occurring number is 1, right? So this is nothing but repetition of observation is called as mode. Okay, now the second thing is frequency and percentage. So frequency and percentage, like suppose out of 100%, whatever is there is your, whatever is the number is called percentage, right? That, see, these observations are out of 50. Okay, so 50 is 100% here, right? Number, the total number of observations is 50 here. Total number of observation means 100% of observations are just 50. So out of 50, if we call 32, out of 50, these will be 64%. Out of 55 would be 10%. Out of 50, 10 would be 20%. Out of 50, 15 would be 30%. Out of 50, 20 would be 40%. So this is the frequency. Out of 50, 32 are male. So this is the male frequency of male is 32, and percentage of the male out of total population is 64%. Blood group A is just 5 people. Okay, this is frequency. So 5 people are blood group A, and this is 10% of the population. Blood group B is 10 people, that is frequency, and this is 20% of the population. Okay, AB is 15, that is 30% of the population. O is 20, that is 40% of the population. Understand? So I think it's very simple. Like if I'm talking about 100 people only, N is 100, so that is 100%. If I'm talking 10 people, frequency is 10, so what is percentage here? 10 only, right? 10 only is the percentage. If I'm asking about 200, N is 200, so N is 100%, right? Now if I talk about 30 people, what will be the percentage? 15 only. Out of 200, 30 will be 15%. Okay, so that is how we go for the percentage and frequency. So this is simple as one, and you might you know that. So this is also the thing we check in the simple distribution or simple descriptive statistics. Okay, now there are some more measure of variations or dispersion. Okay, there are some measures of dispersion. So those measures of dispersions are, you can see here. You can see here. These, there are, you can see 5 leaves. Okay, you can see 5 leaves here. You can see 5 leaves here. But let me tell you guys, area of each leaf is almost same. Okay, area of each leaf is same, because the shape, and I mean it is looking like that area is also not same, but let me tell you, the area of each leaf is same, almost same, but just because of the shape and the distribution of the leaf, or the shape of the leaf, just that is varying. Okay, that is varying. So that means the size is almost, could be similar, but I mean sorry, area is similar, but size and shape of the leaf is different. Okay, size and shape of the leaf is different. And when we are calculating, like suppose if we are calculating the area, multiple things will be influencing the area distribution. Okay, multiple things will be disturbing or influencing the area formula, right? The length, height, whatever, there are things, there are different things, but the area would be almost similar, right? So how to check these differences from some populations? Like there are 5-6 populations, so maybe the mean is similar for 5 populations, right? There are group A in clinical, let's see clinical example. So in the clinical 5, there are 5 examples of groups in one clinical trial. So one, that's mean age is again 36, 37, 35, 36, 36. Okay, mean age is this for all 5 groups, right? And we have taken almost equal age for all the group. But we don't know the individuals in those groups. Okay, this is just the mean age. This is just the mean age, but based on the individual observations, we don't know what is the difference, right? These all 5 groups look similar, right? These all 5 groups look similar because those are just having the mean, similar mean age, 36, 37, 35, 36, 35, 6, right? Similar. But there must be some differences. There must be some lean people, some fat people, some taller people, some shorter people. So individual differences will be there in the groups. So to understand those inside the differences, okay, to understand those inside differences and inside precisions, so to get the precision in the results or outcomes, okay, to get that precision in outcomes and the results, we go for variation or dispersion along with central tendency, along with central tendency. right? So if we are talking about central tendency, based on the central tendency, we go for the variation or dispersion also to check the precise difference, to check the precise difference between the groups, okay, based on the individual observation. And that precision can be done with the help of variance, standard deviation, confidence of variation, coefficient of variation, standard error mean, range, or interquartile range. So let's understand one by one. You will understand there easily. See, this is the group. Okay, guys. Carefully. Let's understand. This is the perfect example I can give you. Okay. There are 10 students. The first group, there are two groups, definitely. There are two groups and heights we are checking. Two groups. One is from first year PharmD, like one is first year PharmD class, one is fourth year PharmD class. We took 10 individuals from each class. 10 individuals from each class, and we are checking the heights. So when we check the height, look at the mean for each group. Mean for group PharmD first year and mean for fourth year PharmD is all similar. Right? Mean is similar. So that means the height of PharmD first year and height of PharmD fourth year is similar. Not almost, it is equal. 5.4 is equal, right? So that means the height of both the classes is equal, right? That do you think that although, I mean, I'm talking about both classes and the height of the both of the classes is similar. So do you think all the students are at the exact height? All the students are having 5.4, 5.4, 5.4, 5.4, 5.4. Is it possible? Not at all. That means there are some internal differences. And internal differences, if you look at the individual heights, 5.4, 5.8, 4.8, 5.9, 4.2, 5.2, 5.3, 6, 5.5. Only some are having the same thing, like 5.8 is similar, 5.5 is similar, right? 5.5 is similar, 5.7 is similar, right? But what about 5.6? No. 5? No. 5.7? No. Right? 4.9? No. 5.2? No. 5.2 is also here. Okay. 5.1? No. So there are the differences. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So still there are 10 differences. Okay. Still there are 10 differences. Individually, if we check, everyone is different. Maybe one category this is same, 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 but otherwise all are individually different, right? So mean is almost same, but there are individual differences. Median are exactly similar, but still there are individual differences. One sec, guys. Sorry guys, I got a call from my mom. Okay, so see, mean is similar for both the groups. Median is also similar for both the groups. Mode is also similar for both the groups. Okay, mode is also same, 5.5, 5.5, right? But now how to check what is the difference? See, there is definitely difference. Okay, there is definitely difference between two groups, right? That individual group, so individual observations are different, but outer side, the cover of both the classes is similar in the height. Okay, cover of both the classes is similar. Mean 5.4, 5.4, median 5.5, 5.5, mode 5.5, 5.5. But it does not mean that everyone is having the same height, right? So in that case, we go for variances. In that case, we go for the precision, and those precision is like standard deviation. See, this is the standard deviation, and you can find out the distribution differences here. here the distribution differences is 0.55, here distribution differences is 0.34, right? Distribution differences means around the central tendency. If I'm writing 5.5, 5.4 for this group, that will be 5.4 plus minus 0.55. If I'm writing 5.4 for this, it will be 5.4 plus minus 0.34, right? So that's how we define the populations precisely, correctly. So that means the height differences in individuals also, this will be either 5.5, 5.4 minus 0.55 or 5.4 plus 5.55. So the range of the population height in group 1 is nothing but, if I check here, that will be 4.85, right? 4.85 to 5.95. Okay, is range of the group, this group is 4.85 to 5.95. Range of this group is just 5 point 0 or yeah 5 point 06 to 5.74. okay, this is the group 2, this is the PharmD 4th year, and this is the PharmD 1st year. Actual difference can be seen here just with the help of precision, just with the help of variance, just with the help of SD, standard deviation. Understand? So that's how we need the precise results, that's how we need the variances, that's how we need the variances, and all the variances values along with the central tendency, because central tendency could be similar, but there must be some differences individually between the groups, right? So to check those differences, we go for the mean, mode, median, and standard deviations. Along with that, standard deviation. So see, standard deviation is nothing but it is the deviation of individual measurements around its mean. Okay, simple, around its mean. So I have described you the standard deviation already, right? So standard deviation means it is showing the actual range of the calculations, actual range of the individual values in a group, right? So there would be one mean, and then there would be one standard deviation which says the range. So how to check it? Range, how to check it, sorry, not range, how to check it, the standard deviation. The formula for standard deviation is this. Formula for standard deviation is this. Standard deviation is known as S under root of exponential x minus x bar cut to n minus 1. So this is the actual value individual, this is the mean, x bar is nothing but mean, so this is the individual value. Okay, this is the individual value. I'm just talking to you the pure mathematics, guys. Okay, you don't have to do this, but everything will be done by the software, but still you should understand how do we check the standard deviation. Okay, so first, this is the individual value. Suppose the individual weight of 58 or individual height or 55 point height, whatever we were checking, individual height is 5.8 of this value, right? Individual value of 5.8, right? So now what is that? This is the individual value, and this is the mean. X bar is mean. Okay, so x bar is mean, that is 5.5, right? That is 5.5. So this is the epsilon, means the sum of all the individual values, sum of all the individual values minus all the means, right? Ka square divided by n minus 1, whatever is the number, minus 1. There were 10 people, so 10 minus 1, only 9, right? Ka under root, right? Ka under root. So there are two things, one is variance, one is standard deviation. If we are not under rooting this, that will become the variance. So variance is nothing but the square of standard deviation. Variance is the square of deviation, and standard deviation is the under root of variance. Okay, that is the simple thing. If you want to understand the variance, you can just under root the, you can just get the square of standard deviation, right? So let's check how it goes. See, let's check how it goes, in the simple formula you will understand. See, there are some 7 values. You can see these are the individual values: 8, 5, 4, 12, 15, 7, 7. I mean 5, 7. And when we check the mean is 8. So how do we get the x minus x bar? X is individual, x bar is mean. So how do we get it? 8 minus 8, 0. 5 minus 8, 3. 4 minus 8, minus 4. 12 minus 8, 4. 15 minus 8, 7. 5 minus 8, minus 3. A7 minus 8 minus 1, right? Now x minus x bar ka square, right? X minus x bar square, 0 square 0, 3 into 3 9, 4 into 4 16, 4 into 4 16, 7 into 7 49. So this is nothing but the sum. The epsilon x minus x bar ka square is 100. Now if we check the standard deviation, simple formula, x, epsilon x minus x bar ka square 100 divided by 7 minus 1. So 100 divided by 6, and the value is 16.76. So this value is nothing but the variance. Okay, and now if we are underrooting this, then the mean, then the SD will come 4.08. Then the standard deviation will come 4.08. Now if we want to write the mean of this entire group, it will be 8 plus minus 4.08. Got it? Simple formula. It is, you can even understand simply. I mean, nobody is asking you in the exam that what is the formula of SD, but simply you should understand why and how to check the standard deviation. How to check the standard deviation. That is the simple formula of checking the standard deviation. First, individual values minus median, then square it, and then sum it, and then divide by n minus 1 ka under root. Simple formula to check the SD. Right, guys? So this is quite mathematical, but you should understand what is SD and why it is useful. SD is quite useful to measure the scatter of the observations. Scatter of the observations, I told you that there will be the range, lower range and higher range. So there will be the scatter of individual observations that can be observed by standard deviation, right? Merits, it is rigidly defined based on all the observations. So we need all the observations. Again, if you have the missed values, if you have the mean differences, you cannot go for SD. If you are following the mean formula, if you're checking the mean, SD comes from the mean, right? And if your mean is influenced, your SD will be influenced again. So if there is no continuous data which is not normally distributed, which has missing values, which has extreme values, SD cannot be counted, and that formula will not help them. And uh, you know, so merits we are talking about, it is suitable for further mathematical treatments like SEM and other parametric tests. Okay, it is for other parametric tests as well, right? So now coefficient of variation. So coefficient of variation is nothing but simply by the formula of, see, coefficient of variation is CV, and it can be done by SD divided by mean into 100. This is the percentage. Okay, this is percentage of mean, nothing but the percentage of mean, and this is also one of the relative measure of variation or standard deviation, called as relative standard deviation. Coefficient of variation is nothing but the relative standard deviation, the percentage of standard deviation, percentage of mean. Okay, percentage of mean that can be calculated by SD divided by mean into 100, divided by mean into 100, and that is called as coefficient of variation, right? So this is nothing but the relative standard deviation, which is called as coefficient of variation. Simple formula, standard deviation divided by mean into 100. Okay, and everything will be calculated by SPSS or the softwares whatever you are used, but you should know how it has come. Okay, how it has come and how it has been related. Right now, if there is one more thing, standard error of mean. Standard error of mean. Suppose when, in that case, when we are checking mean of two groups was same, mode of two groups was same, median of two groups was same, and SD of two group was also same. What will you do to define that differences? What will you do to define that differences? How can you differentiate between two groups now when the standard deviation is also same? So SEM is like precision. Okay, SEM is like ultimate precision. if there is no way to get the difference between individual groups, then we go for SEM. Okay, it is like range in which the true mean is lying. True mean means the precision, the actual mean. So how to calculate SEM? SEM is calculated by SD divided by under root of n. So here we have the SD and we have the n number. We just under root the n, like whatever is the SD, whatever is the n, we'll just under root and divide the SD by that. So that will be calculated as SEM. So usually sometimes when we have similar SDs for the groups, and when we have very small observations, when we have very small differences between the groups, remember guys, when we have very small differences between the groups, in that case we play with SEM. We write mean plus minus SEM, not standard deviation. So that shows the true mean. So usually you can also write SEM, but SEM is a ultimate precision, and SEM means whenever there is very small differences between the mean, wherever there is the very small differences between the groups, so that can be identified by the SEM, standard error of mean. So that is even telling us the error between the means of two groups, right? And that is the ultimate precision, right guys? So I hope you understood this. Now the range is simple, maximum minus minimum, whatever. Like I told you, like see, there are the 5 observations. If you want to check the range of this, then again keep in the ascending disorder, or just check what is largest number, what is the lowest number. So 130 minus 119 is equal to 11. So this is the range of the population. This is the range of dispersion. So the simple measure of dispersion is range, and range can be calculated by maximum minus minimum, highest and lowest. This is the difference between the highest and lowest scores, right? Range is nothing but the difference between the highest score and the lowest score. X max minus X min is your range. So wherever there is a population, just check the highest and then the lowest will be your range. You will get your range. So range does not mean a lot actually. Mean means not that mean, but range does not mean a lot in the observations, in the things. It just tell that okay, in my group the age group is 18 from age group ranges from 18 to 65 of the years of the age. That's enough. Range is just defining their population in one way, but not in the specific ways like central tendency or something. Okay, range is just telling like okay, what are your observations actually. That's all, nothing much, right guys? Understand? Then what is interquartile range? What is interquartile range? So interquartile range, usually there are 3 interquartile range: Q1, Q2, Q3. Simple, as we can understand by the percentage. As if we divide the 100, Q4, so that if we divide the 100, 25%, 25%, 25%, 25%. That's how we give the percentage. As you can see, 0 to 25% Q1, 0 to 25 to 50% Q2, Q3, maximum Q4. So here these each individuals are just adding up. So Q1 is not, Q1 is just 25%. Q2 is 25 this plus 25 this, 50%. Q2 is plus 25 this also, 70%. Q4 or maximum is all 100%. All 100%. So usually the 50% is median. 50% is median because the middlest value is the median. So 50% or quartile 2 is known as median. Okay, quartile 2 is known as median. So quartile does not mean anything, but it is like it is dividing your population into 4 equal parts. It is dividing your population into 4 equal parts, right? If I'm talking about Q1, suppose I'll tell you one more thing. You will understand like this. That is the central tendency. Q1, Q2, Q3, 100%. Okay, so 25% of the population is lying here. Another 25% is lying here. Another 25% is lying here. Another 25% is lying here. This is the entire population lying around central tendency, right? This is the actual population lying around the central tendency, right? Understand? And that's how we divide our population into different quartiles. Interquartile range known as the lower, Q1 is known as the lower or first quartile. Second quartile is value 15%, and this is also the same as median. And third or 75% quartile is the highest quartile. Okay, 100% is the maximum, so we don't write it Q4. That is obviously Q4, but the maximum numbers, maximum range. Okay, guys. So last is confidence interval, that is fiducial limit. Confidence interval is also kind of a statistical segment, and we usually take the 95% of confidence interval. Let me tell you what is 95% of confidence interval. And I told you in the previous classes also, I think. So 95%, why Q3? Okay, someone is asking why Q3? Why Q3 or what is Q3? I think, see, why Q3 is, see, Q3 is important. Why it is important? Why it is important? Because when we are dividing our population into 25%, 50%, and 75, so 75% is also one of the minimum, one of the range of our population. Now, first 25%, second 25%, third 25%. So first 25 is actual 25. Second 25 means, I mean, second quartile means Q2. That is 50%. That is covering or 50% of the population. Okay, quartile 3 is 75%. So let me tell you in this. Okay, let me tell you here. Let me tell you here. This will be here. I'm talking about the quartiles. So this is this is the central tendency. This is like central tendency. Okay, so there is a lot of population. So first 25% will be near to central tendency, very near to central tendency. Then second quartile will be a little far. Okay, then third quartile will be quite far, and the fourth quartile will be too far. Okay, why it is? Because the first people, if I'm giving you the example again of the 100 people, so most of the people of 10th class, most of the students in 10th class are having 14 or 15 years of the age. So this is the first thing which is just near to the central tendency. Q1 first 25%, Q2 also second 25% also just near to the central tendency. But if I'm talking about 75%, that might be a little far away from the central tendency. Okay, and then after 75%, the last maximum will be absolutely far, because this is having all the extreme values, all the positive extreme values or outliers. So Q4 usually shows the outliers. Okay, in the Q4 usually outliers, and this is quite far from the central tendency. So first 25. So if we are talking about total 50%, then we can say this is the median. And 75% is also one of the quartile, which shows that okay, 50 to 70% 70% people are lying somewhere far from the central tendency. And collectively if we say, we can say from here to here we have 75% of the population. From here to here we have, this is 75%, this is 50% of the population, and from here to here we have 25% of the population. So that's how we decide our quartiles. Okay, that's how we decide our quartiles. Now confidence interval. So confidence interval is nothing but fiducial limit, and we usually think that our 5% of the data is having error almost. Okay, always we take that, or we can say in the positive side, we are considering that our 95% of the data is real. Our 90% is, or 90% of the data is having the true mean. Okay, true mean. 95% of the data is completely normal, and 5% of the data is not normal. Not normal means it is not having the true mean. So usually in all the trials, in all the cases, we usually take 95% of the confidence interval. That means we are 95% confident on our data, and 95% of the data is having the true mean. Okay, that is nothing but the confidence interval, and that can be calculated by this formula. So CI, as you can see, CI is equal to mean x minus x bar is mean plus minus 1.96. That is the coefficient. That is the coefficient. That is the Z power 1.96 is the coefficient, and that is having the same 1.96 for the 95% of interval into SD minus SD divided by under root of n. So what is SD divided by under root of n? Guys, what is this? This is SEM, the true mean. This is SEM. This is SEM. So confidence interval can be calculated with the help of mean plus minus 1.96 into SEM. Okay, so we can write it. CI 95% is equal to X bar plus minus 1.96 into SEM. Right, that is how we calculate the CI mathematically. That is how we calculate the CI mathematically, and we usually take 95%. So guys, as I think I told in the last class of when we were checking sample size, when we were checking the sample size, you might have attended this class. That was the first class. So I told this JED, I told this JED, right? So JED has different values. Okay, if we are taking 95% of the confidence interval, JED will be 1.96. If you are taking 90% of the confidence interval, that will be 1.68. If you are taking 99% of the confidence interval, that will be 2.76, so 78. Okay, and if we are telling 19.99% of confidence interval, that will be 3.3 something, 3.36 or something. Okay, these are differing. This Z value is different but constant in different cases. Okay, so whenever we are charging 95% of the confidence interval, this Z will be 1.96. Okay, 1.96. The value of Z will be, power of the study here will be, I mean not power of the study exactly, but the Z usually power of the study is 1.96. Okay, and that differs in different cases. So that's all for today, guys, in the basics of biostatistics. And tomorrow means in the next class, we'll be talking all about the tests. We'll be talking all about the tests on Thursday or Friday. Okay, guys, so any questions till now? Any questions here? What is mean by effect size? See, mean by effect size is nothing. I told in the last class also. Okay, there are population means also, and there is mean by effect size also. So these things are nothing. Okay, these things are nothing. But the simply when we are talking about different population groups and how these variables actually are differing between the groups. Okay, so mean by effect size is nothing but when we are checking the differences between actual population between two or three groups. Okay, effect size, see, when we are checking the mean of one group, that is the simple mean, population mean. But when we are checking the mean between two groups and the sample size in both the groups affects the mean. Okay, sample size in both the groups affects the mean, that is called as mean by effect size. Okay, how? Let me tell you. In the hundreds of this 10th class only, I'll give you the example. If I'm telling you to check the mean difference between male and female, so can you confirm that only 50-50, the number is 50-50 only? No, there will be 70-60 male or 70 females or 60 females or whatever. The ratio will be different. The sample size in each group will be different. Okay, so effect of the sample size on the mean, and then that effect on the difference between the groups, difference on the mean between the groups, is called as mean by effect size. Okay, mean by effect size. Okay, that's nothing special, nothing to especially keep your mind in that. Anything else? Any other questions, guys? Okay, if no questions, we can wind up today, and we'll see you in the next class, guys. Thank you, guys. Take care, guys. Thank you.